A connective light bulb looks harmless because its physical job is simple. But behind the diffuser is a microcontroller, network stack, firmware, credentials, update mechanism, and often a persistent connection to a vendor cloud. That makes the bulb an endpoint. If an attacker compromises it, the light may be the least important outcome. The device can become a foothold inside the home network, a source of traffic, a discovery point, or a bridge toward systems that hold more valuable data. We will whiteboard the complete product, not just the bulb, mobile application, cloud API, identity, router, local protocols, update service, and neighboring devices. Then we will show when a compromised bulb can become a gateway, where segmentation stops the path, and the practical controls that reduce risk without turning a home into an enterprise data center. Draw the product as 6 connected components. The bulb exposes Wi-Fi, Bluetooth, Zigbee, Thread, Matter, or a vendor-specific pairing interface. A hub may translate protocols. The mobile app stores sessions and sends commands. A cloud API authenticates the household and relays remote control. Firmware and update infrastructure decide what code runs. The router connects everything. An attacker needs weakness in only one reachable layer: a reused cloud password, insecure pairing, an exposed local service, a vulnerable app or API, an unverified update, or an abandoned product with no fixes. This is why the bulb has no sensitive data is the wrong question. Ask what identities it trusts, what interfaces it exposes, what destinations it can reach, what traffic it can observe, and which component can update or command it. Initial access usually follows familiar patterns. A reused vendor account password is captured elsewhere and tried against the smart home cloud. A device ships with a weak or shared credential. An unnecessary local service accepts unauthenticated commands. Pairing trusts whoever is nearby. A firmware bug remains exploitable because updates stopped. Router port forwarding or automatic UPnP exposure makes an internal service reachable from the internet. OWASP's IT risk list highlights weak credentials, insecure services and ecosystem interfaces, unsafe updates, outdated components, and insecure defaults. CISA separately urges manufacturers to eliminate default passwords. The first decision point is reachability. Is the bulb directly reachable from the internet, only from the local network, only through an authenticated cloud relay, or only through a hub? Each path changes the threat model and the control owner. A compromised bulb does not automatically control every device. The gateway effect appears when network architecture gives it useful reach. On a flat home LAN, the bulb may discover laptops, storage, cameras, speakers, printers, hubs, and router administration. It can probe exposed services, exploit another vulnerable device, send malicious traffic, or maintain an outbound command channel that looks like ordinary cloud communication. Compute and memory may be limited, but the foothold still has 3 advantages. It is already inside the perimeter, it stays powered, and users rarely monitor it. The critical decision is whether the IoT zone can initiate connections toward trusted devices. If a bulb needs only DNS, time synchronization, and a vendor cloud, it should not be able to open sessions to a laptop, network drive, or router management page. Impact can remain local or expand outward. Light usage and schedules can reveal occupancy patterns. A compromised account may expose household names, locations, scenes, or integrations. The device can participate in a botnet, generate scanning or denial of service traffic, or act as a persistent relay. If segmentation is weak, the attacker can search for a more valuable target: a camera with an old service, a router with reused credentials, a file share, or a management interface. Automations can also create physical effects by coordinating lights, locks, alarms, or environmental controls. Avoid sensationalism. Most bulbs cannot magically read every laptop file. Risk depends on reachability, software flaws, credentials, integrations, and network policy. The engineering task is to reduce the foothold's permissions so compromise of one product does not imply compromise of the home. The strongest household control is network separation. Place bulbs, plugs, speakers, and similar devices on an IoT SSID, guest network, or VLAN. Block that zone from initiating connections to personal computers, work devices, storage, and router administration. Permit only necessary services such as DNS, time synchronization, a hub, and required vendor endpoints. Use client isolation where it does not break the product. Disable internet-side router administration, unnecessary port forwarding, and UPnP when possible. Keep the router updated and use modern Wi-Fi encryption. Be precise. A basic guest network may isolate devices from the trusted LAN, but can also block local discovery or hub control. Test the actual flow. A good rule set documents source, destination, protocol, and business purpose. If the reason is merely it might need this, the connection should remain blocked. Network controls are only one layer. Use a unique password for the vendor account and enable multi-factor authentication. Remove old household members and third-party integrations. Review sessions and security notifications. Enable automatic updates when the vendor provides them. Choose products with documented vulnerability reporting, signed updates, support timelines, and a clear reset process. NIST's Consumer IoT Baseline emphasizes device identification, secure configuration, data protection, restricted interfaces, software update, and cybersecurity state awareness. Maintain a small inventory: product, model, location, network zone, account owner, firmware state, and support end date. When support ends, replace the device or isolate it more aggressively. Before resale or disposal, remove the device from the account, revoke integrations, factory reset it, and confirm that cloud-side data and access are deleted. Finish with the checklist. Inventory every connected device and remove anything you do not recognize. Change default credentials, use unique vendor account passwords, enable multi-factor authentication, and keep the router and devices updated. Put low-trust IoT products on a separate network. Block them from initiating traffic to computers, storage, and management interfaces. Disable unnecessary remote administration, port forwarding, services, and UPnP. Review connected device lists, vendor sessions, DNS activity, and unusual outbound traffic. If compromise is suspected, isolate the device, preserve router and account evidence, reset credentials and sessions, update or factory reset the product, and restore it only after the cause is understood. Do not confuse inconvenience with safety. A smart bulb can be cheap and simple while still carrying network trust. Design the home so one compromised light becomes an isolated device, not a gateway. Copyright 2026 CipherVibe. All rights reserved.